So welcome back. So now the projection of points is completed. It was easy, isn't it? It was easy to understand as well as it was easy to draw also. The exercises were easy to complete. And we have spent a lot of time in explaining these concepts also, because right now we are studying only the basics of projection. We took a lot of time also. So now we move on to the projection of lines, a bit of difficult part. So, by the way, when you complete the drawings, you have to complete the dimensions also. Actually, I forgot to tell it before the first session, during the first session. So you have to complete the dimensions. The dimensions, only 2 dimensions is required here, because we doesn't know the distance of this particular x1, y1 from a dash. So we mark only 2 distances here. And now we move on to the projection of straight lines. In projections of straight lines, we know that straight lines are actually repetitions of points. A one-dimensional repetitions of points is known as a straight line. So in straight lines, in order to represent a straight line, actually what we need is the complete details. The complete details of that particular straight line is both the endpoints. If we know both the endpoints, the positions of both the endpoints as well as the length, then it will be easier for us to define that particular straight line. And with respect to the HP as well as VP, we have different configurations of the straight lines also in 2 dimensions. I mean, in 3 dimensions. In 3-dimensional space, the straight line can be actually placed in a number of different ways, and we will discuss each case one by one, because we start from the easiest, one of the easiest, and then go to the higher up, that is depending on the difficulty level in understanding. So the information that we require regarding a specific line, as for a point, what we required was only the distance from HP as well as the distance from VP was required in order to draw the front view, top view as well as side view. In order to draw a straight line, what we required is its length, then its position of its ends with HP and a VP. So that constitutes 5 dimensions. That is, length is one information that we required. Position of its ends with HP and VP. So if a position is to be determined, if the position of one of its ends is to be determined, the distance of that particular end from HP as well as VP is required. So that it constitutes 2 information. And for the position of the other ends, not the other 2 ends, to the other end, again 2 information is required. So it requires at least 5 informations. So whenever you get a question regarding a straight line, if it doesn't carry all these 5 informations, it may not be the same these 5 informations, at least 5 informations. If it doesn't carry, then the complete solution is not possible unless we assume some specific values. There will be some questions that is coming up without a specific value or specific dimension which is required. So in that case, we assume a dimension or we assume a particular information for that particular question. So that we will discuss when we solve some of such problems. So right now what we consider is we know the length as well as the position of that particular line with respect to its ends, the ends of both the ends of this line with respect to HP as well as VP we know. And then the other 2 inclination, I mean the 2 dimensions that is important is the inclination of that particular point with HP and VP. So that constitutes another 2 dimensions or 2 informations that is possible. So out of all these, there are actually different some 19 or 20 different informations that is possible regarding a projection of a line. So out of which we need at least 5 of them in order to draw it, in order to complete the drawing uniquely. Otherwise, depending on the assumptions, the value can change, the drawing can change. So then the different orientations that is possible. We are not considering the orientation with respect to the profile plane. We are considering only the HP as well as VP. So according to this, or with respect to the HP and VP, there are 6 different orientations possible, 6 different orientations. And we will discuss each one of them in succession. So the first one is a line which is perpendicular to HP and a line which is parallel to VP. So this is the condition, the line perpendicular to HP as well as parallel to VP. Let's see how it will look like. That is a line which is perpendicular to HP and parallel to VP. This is the condition. I hope you can see. This is the line, this yellow line. Yellow is the line. And you know, this is the green thing, that is the HP, and the blue thing is the VP that we normally considers. So this line is parallel to VP. Now it is parallel to VP and perpendicular to HP. So like this. Now if we go for the front view, see, the front view is a straight line. The front view is a straight line which is now perpendicular to the XY line. Here, this the bottom line, this highlighted line right now. This is the XY line. Actually, it is an edge, but it can be considered as the XY line in our 2 dimension. So this line is the front view. This is the front view. So the front view is perpendicular to the XY line. And if we go for the top view, so this is the top view. Actually, we cannot see it. Why we cannot see it? Because it's just a point. Because we are looking from the top and the line is perpendicular to the HP. What we can see is we can just see a point there. You place a pen in front of you in such a way that the length of the plane is perpendicular to your eye. In that case, you can see only the end of that particular pencil. So likewise in this here also, we can see only the end of that particular line. So that is only a point. Since the lines constitute succession of points, the side view, the top view of this particular line will be a point. And this point is the distance of this point from the XY line will be somewhat, we doesn't know. It depends on the question. So the distance of that particular line from VP will be equal to the distance of this particular point in top view from the XY line. So that let's see how it is being done. It is being drawn. This is the 3-dimensional representation of the object, which is drawn in Creo students version. So this is how this particular line will look like in 3-dimensional plane. Now let's move back to our presentation. So the line perpendicular to HP and parallel to VP. And then the second condition is a line which is perpendicular to VP and parallel to HP. Now the line is, the role is reversed. That is, the line is now perpendicular to VP and parallel to HP. How it will look like, let's see. So now, so this is the condition. So in this condition, the line is perpendicular to VP. The line is perpendicular to VP and parallel to HP. See, line is parallel to HP and perpendicular to VP. So if we go for the front view in this case, if you go for the front view, see the front view we cannot see. So actually it is just a point. See, it is just a point. And if we go for the top view, wow, it is a straight line which is perpendicular to the XY line. This line, this highlighted line, this orange line which is right now highlighted represents the XY line in this case, in the top view. So in this top view, it is a straight line which is perpendicular to the XY line. So that is when the line is perpendicular to VP, the top view will be a straight line which is perpendicular to XY line. And when the line is perpendicular to the HP, the front view will be a straight line which is perpendicular to the XY line. And in both the cases, since the point is, since the line is parallel to one of the planes. In this case, the line is parallel to, when the line is perpendicular to the VP, the line is parallel to HP. So when the line is parallel to HP, the top view will be of the same length as that of the original line. So that also we can see. Now coming back to our position in presentation. The third condition is a line which is parallel to both HP and VP. A line which is parallel to both HP and VP. Today we will discuss only up to this, that is the third condition. So the line is parallel to both HP and VP. So in that case you can see here. So this is a condition where the line is parallel to both HP and VP. So see, the line is parallel to both HP as well as VP. Here is HP and here is VP. So the line is this one, and which is parallel to both HP as well as VP. I hope you are able to understand it. You can visualize it. So it is parallel to both HP as well as VP. So now if we go for the front view, see, the line is a straight line which is parallel to the XY line. In this case, the line is parallel to both HP as well as VP. It is not perpendicular to any of the lines. Since it is not perpendicular to any of the lines, the line is not perpendicular to XY line. So now the line is parallel to HP. So the front view is parallel to the XY line, and the length of that front view will be equal to the length of the straight line itself. So now if we go to the top view, it will be again a straight line which is parallel to the XY line. See, this orange line represents the XY line. So it is again equal to the, or it is the top view. So the top view will be a line which is parallel to the XY line, and the length of that particular line will be equal to the length of the actual length of the object, or actual length of the straight line. Now coming back to our presentation, there are three more conditions that we will discuss in the next class, but I'll just name it. One is line inclined to HP and parallel to VP. We will see it in next class only. And line inclined to VP and parallel to HP. And then the last condition, line inclined to both HP and VP. And in the sixth condition, we will focus more. We will be focusing more on the sixth condition because it is the most difficult among all these drawings, and most of your questions are focused on that one, the line inclined to both HP and VP. So now let's see one of the conditions, that is a line perpendicular to HP and parallel to VP. That I have already shown it in trio, but how it can be represented in pictorially as well as in two-dimensionally. Let me show it. So this is VP. We already know this is how it looks like, and this is HP, and now this is the line XY line, and here is the line, this red line, that is the line that is under consideration. We consider this line which is perpendicular to HP and parallel to VP. Now we know the endpoints. We name the endpoints as A and B, capital A as well as capital B. In the object, in the actual object, the names are given as capital letters. So this is capital A and capital B. In order to get the front view, we look from this side. To get the front view, we look from this side. And both A as well as B is projected to the VP. Both A as well as B is projected to the VP. So that this point will be A dash. Since it is the projection of A, it will be A dash. And this point, this point will be B dash. It is the front view of B. So now we join A dash as well as B dash. So this is the front view. This line is the front view. So it is A dash and B dash. So this line, as we know, it should be perpendicular to the XY line. And the length should be equal to the length of the original length of AB. The point, the line, the straight line AB should be equal to the length of A dash B dash. So, or the length of A dash B dash should be equal to the length of AB. Now, in order to get the top view, we look from the top. And since when we look from the top view, and if we project point A in order to get the top view, then that particular projection ray, the ray of projection, will be passing through B. Since the ray of light in our case should be passing perpendicular to, should be traveling perpendicular to HP, and the line AB is already perpendicular to HP. So it will be passing in such a way that it will be passing through B, the point B also. So we will be getting only a single point as point of projection, or the top view of AB. So this is point A, then B. We always name it with the A, then comma B, because here the point A is on the upper side or towards the viewer. Whichever point is towards the viewer, that we will give it as first letter in the view. So if A is here, so then only AB. If B was here, it should have been BA. Because we consider the point B, capital B, to be invisible when we look from the top view. We assume that it is not visible to us. Because of the point A, point B is not visible to us. So that is why we give it as AB. Now, this is the top view. Now we convert this one into two-dimensional drawing. So for orthographic pattern, that is two-dimensional drawing, it will be like this. This line, XY, you know how to draw it. Now we draw a perpendicular line or a projector line so that we can mark the top view and front view on it. This perpendicular line will be representing the projector line as well as the front view also, since a part of it will be representing the front view. Since in this figure, A dash, B dash, etc., both the points are in the same line, in the same vertical line, in the same line which is perpendicular to the XY. So in the front view also it should be in the same line. So here it is in the same line, and AB is also in the same line. So now we get the front view as well as the top view. And in this point, the distance between B and HP, the distance between B and HP can be marked here. This distance should be equal to the distance of point B from HP, and this distance should be equal to the distance of point A from HP. If we know the distance of point A from HP, and this distance should be equal to the distance of, or the length of the line AB, and now this distance should be equal to the distance of the line from VP. Since the line is parallel to VP, the distance will be same even if we measure from any point. So the distance of the point line from VP is marked in the top view. So this is the orthographic projections of this particular condition. So when the line is perpendicular to VP and parallel to HP, this shape will be reversed. So it will be, the AB will be here, AB will be below the XY line, and A dash B dash will be a point above the XY line. When we consider the line to be in first quadrant itself, we mostly consider the line to be in the first quadrant unless and until it is specified like that it is not in the first quadrant. So this is the condition for a line which is perpendicular to HP and parallel to VP. By this time you might have noted that the front view as well as the top view, A dash as well as A, this is the front view as well as top view of the same point A, point capital A, and you might have already noted that the front view and the top view of the same line, same point, not same line, of the same point is lying on the same projector line. The front view as well as the top view should be lying on the same projector line. And likewise, B dash as well as B, C, B dash as well as C, both the front view as well as the top view are lying on the same projector line. B dash as well as B is on the same projector line. So For any point in orthographic projections, the front view as well as the top view will be lying in the same vertical line. That particular vertical line is known as the projector line. So the projections, the front view as well as top view of any line, any point will be lying in the same projector. This is a concept, or this is a fact that you have to keep in mind. And that is important for drawing or for completing our drawings, most of our other drawings also. So that is the front view as well as top view of a point will be lying in the same vertical line, same projector line. That you should never forget. Now, front view is a vertical line showing the true length, and the top view is a point. So when we say true length is the actual length of the line. There are some terms that is associated with the projections. One of them is the true length. True length means the actual length of the object. So in this case, the front view will be giving you the true length. Here, this distance, the distance A dash, B dash will be the true length of the line. True length means the actual length of the line. And now we move on to the case 2. And the case 2 is the line parallel to both HP and VP. When the line is perpendicular to VP and parallel to HP, the role is reversed. So that in that case, the views will be like this. This will be our XY line, and here it will be A dash. Sorry, it will be first will be B dash and then A dash, B dash, A dash. And then we have to draw a vertical line, and here it is A and here it is B. So it will be like this. So this has to be a bit thicker. This line is to be a bit thicker. So in order to make it thicker, I draw it 1 or 2 or 3 times, but you don't have to draw it like that. You have to draw only once using your H pencil, or using your H pencil, you have to draw it once, giving a bit more higher pressure than that used for drawing this projector line. So AB, so this will be a line, this condition will be the condition where the line is parallel to HP and perpendicular to VP. That condition will be this one. So now the next condition, that is the line is parallel to both HP and parallel to VP. So the pictorial representation, this is VP and as well as HP along with the XY line, and here is the line AB. This is the line AB. In order to get the front view, the observer has to look from here, and the points A and B is projected towards the VP in order to get A dash as well as B dash and front view. So this is A dash, B dash and front view. So in this case also, this length, this A dash, B dash will be having a length equal to AB, because this exactly creates a triangle. Sorry, not triangle. I'm sorry. It exactly creates a rectangle in which this distance, this orange distance or red distance is equal to this black distance, and the gray distances are equal. Since this line AB, the line AB is parallel to VP, the distance of A from A dash will be equal to the distance of B from B dash. So this distance as well as this distance is equal, and this is a 90 degree as well as this is a 90 degree. And here also this is a 90 degree and this is a 90 degree. So this distance is equal to this distance in the actual three-dimensional drawing. I mean three-dimensional representation. Now in order to get the top view, the observer looks from the top, and the points A and B is projected to the HP, and here we obtain the front view. Sorry, I mean top view. We obtain the top view AB. In this case also, here also, this AB, capital AB and as well as small ab. This represents a rectangle in which this small ab is equal to capital AB. The distances will be equal. Why? Because this line, the capital AB is parallel to the HP. Since it is parallel to HP, this distance is equal to this distance, And this angle is, these two angles are 90 degree, that we already know, and these angles are also 90 degrees. So which makes it a rectangle, and in a rectangle you know the opposite sides are equal. So capital AB should be equal to small ab. So in top view also we will get the true length, that is the actual length. So this will be the two-dimensional representation of a line which is parallel to HP as well as VP. In this case, the front view A dash B dash as well as the top view AB will be giving the same length as the actual object. See here also the point A dash as well as A is on the same perpendicular line to XY. Same line which is perpendicular to the XY line, or in the same projector line. The points B dash as well as B is on the same projectors. So this you should keep in mind, that is the two projections, the front view as well as top view of a point will always be in the same projector. The front view and top view both are parallel to the XY line and both show the true length. So that is it. The front view as well as top view both are parallel to XY and both show the true length. So these are the three different conditions. That is, a line is perpendicular to HP and parallel to VP. That is the first condition. Then a line is parallel to VP and parallel to HP and perpendicular to VP is the second condition that we have described. And the third condition is a line which is parallel to both HP and VP. So that is the third condition. So these are the three conditions that we will discuss today. Now I'll give you a few exercises. One exercise from each of these three conditions. So you can start writing the question and then complete the drawing. The drawing, first I will describe it, how to draw it, and then you can draw it, you can complete it. So the question is, a line BC 50 millimeter long is parallel to VP and perpendicular to HP. So in this case, the line is parallel to VP and perpendicular to HP, our first condition. So then draw the projection if the end B is in HP and 20 millimeter in front of VP, and the line lies in the first quadrant. So that is the condition. A line BC 50 millimeter long is parallel to VP and perpendicular to HP. Draw the projections if the end B is in the HP and 20 millimeter in front of VP and the line lies in the first quadrant. So in this case, the five data or the five informations that are given are, the first one is 50 millimeter long. The line BC is 50 millimeter long. That is the first information. And the second one is the line is parallel to VP. And the third information is it is perpendicular to HP. So there are three information. Then draw the projection if the end B is in HP. So end B is in HP. That is the fourth information. And the point B is in 20 millimeter in front of VP. That is the fifth information. So five informations are there. So these are the five informations that is required. There are five information, at least five informations, and hence there will be only a unique solution in this particular program. So in order to draw it, first what we have to draw is we have to draw the XY line in any of the projections. The first step is draw a horizontal line and name it as XY line. So in the first step we draw the XY line, and now we mark, since the point is in HP, since the point B is in HP, B is in HP means the front view B dash should be in XY line, that we know. The point B dash, the front view of B should be in XY line. So we mark a point arbitrarily at any distance, that is B dash, and that particular point is on XY line. And then we draw a line which is perpendicular to the XY line, and the distance of this line is to be 50 millimeter long, and this line represents the front view. Since we know when the line is perpendicular to HP, the front view will be perpendicular to the XY line. And in this case, the point B, the end B is in HP. The end B is in HP, so the front view of B should be in XY line. So that is why B dash starts at XY line. So then B dash C dash is 50 millimeter long. Then in order to represent the top view, we draw the projector line to the bottom of XY line. That is below the XY line, we extend the projector line below the XY line, and in this line we mark a distance 20 millimeter. Since the distance of the line from the VP is visible only in top view, the 20 millimeter is visible only in top view. So we mark that particular distance 20 millimeter from XY on the projector, and that particular point will be the point CB. Why we use C first? Because it is the point which is nearer to the observer. The observer looks like this. See, here is the observer, and observer looks like this. And point C is nearer to the observer, and B is away from the observer. So what we commonly do is C comma B can be used, or C within bracket B can also be used. Within bracket is the preferred notation, because whatever values or whatever notations that you give within the bracket, those points will be invisible or not visible lines. So in this case, C is visible and B is not visible. So that is why it is CB, C and within bracket B. And now you have to give the dimensions also. And that's it. This is the answer for the first question. So now we move on to the next question. The next question, it is a line CD, again 50 millimeter long, is perpendicular to VP and parallel to HP. In this case, the line is perpendicular to VP and parallel to HP. In the previous case, it was the reverse, that is, it was perpendicular to HP and parallel to VP. And draw the projection if the end C is 10 millimeter in front of VP and 15 millimeter above HP, and the line lies in the first quadrant. So here the line is perpendicular to VP and parallel to HP, and one of the endpoint C is 10 millimeter in front of VP and 15 millimeter above the HP, and the line lies in the first quadrant. So here the 5 information that is required are the 15 millimeter long, then line is perpendicular to VP, parallel to HP, and end C is 10 millimeter in front of VP and 15 millimeter above HP. So the 5 informations are there. So write down the question. Okay, now how to draw it? So first to draw the XY line, as we said, XY line. Now we draw a projector. Since the point is not lying on XY line, none of the points is lying on the HP or VP. None of the points is lying neither on HP nor in VP. So we have to use projector lines. So we draw a projector, and this projector is specifically used to draw the top view of C, point C. The top view as well as front view of point C is to be drawn in this particular projector. So point C is marked 10 millimeter in front of or below the XY line. Since the point C is in front of VP, 10 millimeter in front of VP, we have to mark the point C 10 millimeter, like top view of point C, that is small letter C, 10 millimeter below the line XY line. So, and then extend that particular projector to 50 millimeter. So this is point B. So CD, that is the top view, is obtained. Now extend the projector above the XY line also. That is to draw the front view. That particular distance should be 15 millimeter. So 15 millimeter above the XY line, we mark point B dash C dash. Here B comes first. B comes first because when the observer looks from this side, D comes first. Since D comes first, D dash comes first, and then within bracket we use C dash. So this is D dash C dash, and then give the dimensions. Then here there will be a 10, as well as here the length of the line 50. In the previous case, since the point was lying on XY line or lying on HP, so one distance was missing, but here we need all the three distances, that is 15, 10 and 50. So that is the condition for the second question. And I'll describe the third one also, and after that you can complete it together, because this is very simple. And in the third case, a line AB, 50 millimeter long, is parallel to both HP and VP. In this case, the line is parallel to both HP and VP. And the end A is 20 millimeter above HP and 15 millimeter in front of VP. Draw its projections. So here the line AB, the five informations that is required is 50 millimeter long. So that is one. Then parallel to HP, parallel to VP. So two information. Then in the A is 20 millimeter above HP and 15 millimeter in front of VP. Five informations are there. And in this case, the point A is 20 millimeter above HP and 15 millimeter in front of VP. All the points that is lying on this particular line AB should be 20 millimeter above HP and 15 millimeter in front of VP. Why? Because the line is parallel to both HP as well as VP. So like this. So this is the XY line. Now we mark point A dash. Point A dash is 20 millimeter above the HP. So A dash is marked. And the point A is also marked. A is 15 millimeter in front of VP. So the projections of A dash as well as A is drawn first. So this is point A dash as well as point A. Then draw a horizontal line or a line which is parallel to XY line passing through A dash. And the distance of this particular line which is passing through A dash and parallel to XY line should be equal to 50 millimeter. Since the length of the actual line, the length of the line is 50 millimeter, the true length of the line is 50 millimeter, and the line is parallel to both HP and VP. The line is parallel to both HP and VP. So when the line is parallel to VP, the front view will be giving you the true length. You might have noticed it. When the line is parallel to VP, the front view will be giving you the true length. And when the line is parallel to HP, the top view will be giving you the true length. That we will discuss later, but you might have already understood it. In the previous case also, in the previous two cases, when the line was parallel to HP, the top view was giving you the true length. And when the line was parallel to VP, the front view was giving you the true length. Here also, since both are giving parallel to HP as well as VP, that is, the line is parallel to both HP and VP, both the views, that is front view as well as top view, will be giving you the true length. So first you mark the points A dash as well as A, that is the front view and the top view of the line, the point A. Then on the XY line, and the length of this line should be equal to 50 millimeter. So this is point B dash. Now a same line, a similar line is drawn from A also. From the top view of point A is drawn. Similar line is drawn, that is a line which is parallel to the XY line and of length 50 millimeter, and this is the point B. And if we draw a perpendicular line or a perpendicular line to XY line, it is a line which is perpendicular to the XY line and passing through B dash, it should pass through the point B also, like this. See this line as well as this line. This line is a same straight line, and it passes through B dash as well as B. Since we know that the front view as well as top view of the same line, same point should be lying in the same projector line. This is the projector, and if B dash is here, B should be within that particular line, within that particular projector. And now you have to mark the dimensions also. In this case, 3 dimensions, the distance of A from HP and VP, that is 20 millimeter and 15 millimeter respectively, and the true length or the length of the line. So that is 50 millimeter. Don't draw it inside this figure. A common practice that we have seen in students is that they draw the length of this line, the length of the lines inside this figure. Don't draw it inside the figure. Either you can draw it at the bottom of the figure or towards the top of the figure. Even if you measure A dash as well as A dash and B dash, it will be similar to the length, or it will be same as AB. So it doesn't matter. But don't ever draw it inside the figure.